Types of future value analysis. Yeah, single sum analysis. Multi-year cash flow. Under multi-year cash flow, you have uneven cash flow and annuities. Under annuities, we have ordinary annuities and annuity due. Note, compounding applies to both single and multiple cash flows. Single sum analysis. It determines the future value of a single investment placed now. Examples are as given in illustration 1 to 3 previously. The future value equals to PV times bracket 1 plus K bracket to power n, or the table format. Use the table FVIFA table format. Recap of illustration 1. You place $1,000 on bank deposit at 10% with annual compounding interest. How much would you have in the bank at the end of 3 years? So its PV is 1,000, K is 10, N is 3. So we are trying to find FV at the end of 3 years. The timeline is drawn here for better understanding. We are using the formula, the table formula. Substitute the figures in. K is 10% and N is 3. We find the answer from the FVIF table. Substitute this figure in and work out the answer is 1331. The above equation could be used to calculate any other variables as long as the other 3 variables are given. So there are 4 variables here. As long as 3 are given, any of the 3, we can find the 4th one. Multi-year cash flow determines the future value of a series of dollars invested. So you have cash flow at time 1, CF1, CF2, and CF3. And usually the 3 cash flow are of different amount. So CF1, CF2, and CF3, individual sums invested at the end of each year. It could be the same, it could be different or the same amount. So after that, you add up all the 3 figures, you find the total future value. Uneven cash flows. Future value of an uneven stream of cash could be obtained by determining the future value of each individual cash flow. So basically, you determine each one of them. For example, CF1, you find out the future value for CF1. Then you find out the future value for CF2 and find out the future value for CF3. Each individual cash flow is determined separately. Then we'll add the individual cash future values together and we'll find the grand total future value. Illustration 4. You deposit $1,000, $2,000, and $3,000 at the end of year 1, 2, and 3, respectively at 10% annual compounding. How much would your total investment be worth at the end of 3 years? K is 10%. So $1,000 at year 1 and year 1. We're looking at finding for FV1. We have $2,000 at end of year 2 and $3,000 at end year 3. and we'll add up all this figure to find the total future value. We'll be doing one cash flow at a time. First, we want to find n. So it's 1, 2. So n is equals to 2. We are using this formula. Substitute the figures in. From a table, FVIF table, find the answers. One is 1.210. So substitute that figures in, and we find the answer is 1,210. Let's look at the next cash flow. We want to find n. So it's one period only. So n equals to 1. We use this formula. Substitute figures in. From the table, we find out the answer is 1.100. So substitute the figure in, and the final answer is 2200. Let's look at $3,000. It has a 0 compounding period. So n equals to 0. Using this formula, substitute all the figures in. The period is 0. The n equals 0. The FVIF will be 1 equals to 1. So it's 3,000 times 1. So the figures will be 3,000. Okay, we have found out the FV for FV1, FV2, and FV3. Next, we add them all up together, and the grand total is 6,410. This is the future value of all the deposit at the end of year 3. Let's have a quick recap for illustration 4. This is today. This is the cash flow given to us. This is the end of the first period, period 1. There's 2 compound period. This is end of period 2. Yes, 1 compounding period. And this end of period 3 and 0 compounding period. So we know that if 0 compounding period, the FVIF answer will be equals to 1. Then at the end of the year, we add up all the FV to find the total FV.